Hello and welcome to this introduction to taming helicopters in flight sims. I will be focusing on how our inputs through the cyclic, collective and anti-torque pedals affect the helicopter and fundamentally how we need to use these together to maintain control. Each video clip is intended to be relatively short to deliver this information in bite-sized chunks, so I won't be delving into in-depth textbook explanations. There are a number of really good videos out there already explaining these technical details. My aim is to provide a practical hands-on approach to reduce the learning curve and hopefully speed up your progress through a series of demonstrations and explanations. Throughout these videos I will be using the HUI in Digital Combat Simulator, otherwise known as DCS. The flight model of helicopters in DCS is very good, as is the HUI's, which I find handles as I would expect and provides great feedback, making it a solid choice. For X-Plane 11 I would recommend using the Dreamforce Bell 407, and for Aerofly 2 I understand the default Robinson R22 is exceptionally good. Other helicopters are of course available. Whatever helicopter you choose, I would suggest doing your research and use one that is widely approved or accepted as having a realistic flight model. As you can appreciate, in a simulator we are missing a lot of physical feedback a real-world pilot would take for granted, like the forces acting on our body or even the sensation of movement itself. In a simulator we may need to rely on our instruments a little more to maintain our situational awareness, so I'll run through the more useful or important ones to us now. First up is the vertical speed indicator, or VSI. Managing our descent rate in a helicopter can be critical, so this instrument is very much our friend. It displays our rate of altitude change in feet per minute, each division representing 100 feet. Next, the altimeter, a standard gauge providing an altitude based on atmospheric pressure. Largely, we'll use this for reference. Typically we'll be flying low and relative to the terrain. The artificial horizon. Crucial in poor visibility and a good reference when the horizon is obscured by hills and mountains. Our indicated airspeed in knots, again mainly used for reference. Alterations to control inputs will be based on how the helicopter is reacting to speed changes rather than watching this gauge. Engine and rotor RPM, not too much to say about this right now, basically keep these in the green, which in normal flight should not be an issue. The radar altimeter, measuring the actual distance between the helicopter and the terrain. This can be a useful reference, for example to confirm whether or not we're in ground effect. The turn indicator, in all honesty of very little value in a helicopter. Fly intuitively and adjust your inputs based on how the helicopter reacts. Finally, the torque, gas producer and exhaust gauges, quite simply keep these in the normal operating parameters and avoid exceeding the red line. Our first demonstration coming up is going to be a simple example of how the helicopter reacts when we raise the collective to take off, and to illustrate how or why we also need to use the anti-torque pedals and cyclic. Before we jump into this, now would be a sensible point to go over the basics of the three primary controls. We'll start with the cyclic, perhaps the hardest of the three to master. Moving the cyclic to the left will induce a bank or roll to the left. Correspondingly, moving it to the right will roll us to the right. In both cases we'll move in the same direction. Pushing forward on the flight stick pitches the nose down and we move forwards, or increase our forward speed. Pulling back on the cyclic will cause the nose to pitch up and we'll slow down and or move backwards. Next we have the collective. Raising the collective increases the rotor blade's pitch, increasing our lift. Lowering it does the opposite, causing the blades to flatten, reducing lift. And finally we have the anti-torque pedals. Pushing forward on the left pedal yaws the helicopter to the left, allowing us to compensate for torque or change our heading. And as you can probably work out, the right pedal also allows us to adjust for torque or yaw the helicopter to the right. For this demonstration we're going to leave the anti-torque pedals and the cyclic in their neutral or centered positions so we can demonstrate how the helicopter reacts when we simply lift the collective to take off. The red graphic at the top left of the screen indicates our control positions. We will now slowly raise the collective without moving the pedals or cyclic to observe how the helicopter reacts. As we become light on the skids, the helicopter initially yaws and rolls to the right, then quickly starts moving forward as the nose pitches down. It continues to lurch around as the speed builds before going into a rather uncontrolled right turn as we continue to climb out. As the runway comes back into view, I regain control by moving the cyclic left to roll out of the turn, then continue to use small inputs on the cyclic and collective to establish a steady airspeed and altitude. In the next video we will revisit taking off, but this time using a controlled and safe procedure to stay ahead of the helicopter to place ourselves in a controlled hover. Finishing off for today, we will talk briefly about hardware controllers, as these can make a substantial difference to how easy or not it may be to attain a good level of control. As you can see from the red graphic, to maintain altitude and airspeed we need to maintain forward pressure on the cyclic. The majority of joysticks have a centering spring. This can be tiring on your wrist and makes fine cyclic corrections more difficult during a hover or precise movements. For flying helicopters, removal of the spring is advisable. Alternatively, compressing the spring with cable ties where possible is also a good option. A joystick with a twist grip for anti-torque input and an integrated slider assigned as our collective should be regarded as a minimum requirement. While controllers specifically for helicopters are available, there are limited choices, and unfortunately because of their bespoke nature they are comparatively expensive. Not surprisingly, the cost is too prohibitive for some and too expensive for others to justify. The more common option is to utilise a HOTAS system for cyclic and collective and a set of rudder pedals for anti-torque pedals. Bye for now, catch you next time.